In a hydrogenation reaction, the functional group transformation is a reduction from an alkene to an alkane. For the regiochemistry, if you had a more substituted and a less substituted alkene in the molecule, the less substituted alkene would react faster due to sterics. And the stereochemistry is syn, meaning that the hydrogen are added to the same side of the double bond. So in this hydrogenation reaction, we have a metal catalyst, the surface, and the hydrogen comes in and kind of plops down on the surface, and then the pi bond goes to the hydrogens and kind of picks them up to be reduced. So let's go ahead and watch a quick movie on how this works.
A specially prepared metal surface of nickel or palladium contains active sites symbolized by the blue spheres at which a surface reaction can occur. When ethylene and hydrogen are exposed to this surface, they are adsorbed in a process called chemisorption. The H2 molecules dissociate into hydrogen atoms, bound to the surface but able to move about on it. When an adsorbed hydrogen atom encounters an adsorbed ethylene, it may add to one of the carbon atoms, forming a new CH bond. A second hydrogen atom then adds to the other carbon atom, forming ethane, which dissociates from the surface.
All right, so both of those hydrogens add to the same side. And as I mentioned, when we have less sterically hindered double bonds, those are more easily able to complex to that catalytic surface. So the less substituted alkenes are more reactive than the more substituted alkenes are. A final note, this is a really common reaction industrially. It's used to prepare margarine from vegetable oil. So you start with your cis double bonds and you hydrogenate them to give you the more saturated margarine product. This reaction can actually go back in the other direction, but when it does, the more stable double bond forms, and those are trans fats.